Hello and welcome for the trailer for this presentation on advanced modeling techniques for efficient crop irrigation. I am Cédric Pradalier and I'm part of CNRS. So in this project we look at the smart irrigation, which means that in a normal crop there is some water that gets evaporated by the crop, and irrigation is there to compensate for this evaporation. The way to measure this compensation is to actually use an eddy covariance tower to predict how much water has been consumed. Now, in some situations, this eddy covariance water is not very reliable, and what we want to present here is a solution to use neural networks to predict evapotranspiration just with simple weather station data. So we'll address one objective, which is gap filling. So we have a situation where we have eddy covariance data and evapotranspiration which is missing, and we'll use a neural network to use the combination of what happens before and after with the weather station data to predict what's missing in the gap. That's what we see on this first slide. The method is based on deep neural network inspired from natural language processing, which is interesting because it has high generalization capabilities. It doesn't use any information about the day of the year, the type of crop development, the days from germination, and it uses only a limited amount of data around the gap. We also present results from a real experiment where we use the same network to predict the actual water that was evaporated in a field using only weather station data. And we compare this experiment with a reference irrigation strategy which was based on full knowledge about the soil state. Overall, this showed that with our smart neural network we could achieve a yield similar to what an expert control irrigation was achieving, with an amount of water that was pretty much the same as what the expert was using, but without using expensive and complicated sensors. In summary, so we're presenting a network model which has strong generalization capabilities to predict cyclic time series. Because it's trained, it's actually quite robust on the quality of the data around the gaps, and it can be used to any situation which requires this type of cyclicity. We also experimented in a real crop, and we showed that the neural network is on par with what expert prediction are achieving in terms of productivity and water consumption. And all that without using any complicated data, but only the weather station data.